We have a request to do some derivatives here. Let's look at the function f of x equals 1 over 3x cubed minus 1/2 x squared minus 6x plus 4. First thing we're going to do is find f prime of x. So k of x, which equals f prime of x, equals, well, for this first term, we use the power rule. To do that, we bring the exponent out in front. 3 times 1/3 is 3 over 3, which equals 1. So we can imagine there's a 1 right here. And then we put the variable. And we reduce the power by 1, so that's x squared. The next term, negative 1/2 x squared. So once again, we bring the power out in front. 2 times 1/2 is 2 over 2, which equals 1. X. And then we reduce this power down to 1. So that'll just be x. Next term, negative 6x. There's a 1 right here. X is just x to the 1, so we bring the 1 out in front. 1 times negative 6 is negative 6. And then we reduce the power to 0. X to the 0 is just 1, so there we have it. Let's do the next one. K prime of x equals f double prime of x, which equals, well, same kind of story. We bring this power out in front, and we have 2. We reduce the power by 1, that's just x. And then for the next term, we see that this is x to the 1. We bring the 1 out in front, that just becomes 1. We reduce the power to 0. X to the 0 power is 1. And then the constant goes away. So there we have it, first and second derivatives. I hope this is helpful. Share it with somebody who needs help. Give it a like. Follow me for more content like this. Alright, in part 1 of this series, we looked at this function here, and we found the first derivative, like that. And the second derivative, which was that. If you haven't seen part 1, check it out. It's pretty chill. So now we're looking to find k of negative 1. And that just equals, well, we just plug in negative 1 everywhere that x is. And that gives us 1 plus 1 minus 6. And that equals negative 4. And then k prime of negative 1 equals 2 times negative 1 minus 1. That's just negative 2 minus 1, which is negative 3. Alright, hope that helps. I'll see you for the next one. What does a function's derivative look like? Let me show you. Let's look at f of x. Looks something like that. And that's just coming from up here. Now how about its derivative? Its derivative is a parabola. It's like that approximately. That's f prime of x. In the previous video, they called that k of x. And that's fine. K of x is right here. So let's look at a point. Let's look at an x value of negative 1 on our original function. So that point is up here. Okay. How about negative 1 on its derivative? That point is down here. And we actually know what that point is. We found it in the last video. Negative 1, negative 4. So that negative 4, the y value on the derivative function, is actually the slope of the corresponding point with the same x value on the original function. So that slope is negative 4. That's what the derivative function does. Okay, so we're asked to find the tangent line and Taylor form of k of x at x equals negative 1. So let's just write down the formula first of all. It goes like this. L of x equals k of a plus k prime of a times x minus a. Okay, now we can just plug in our values. Say L of x equals, and we're looking at where x equals -1, so that's our a value. So k of -1, -1 plus k prime of -1 times x plus 1. And we found those values in the last videos. We have k of -1 is -4, and k prime of -1 is -3. So L of x equals what? -4 minus 3 times x plus 1. We're just plugging in those values. So what is that? What is that L of x? That is just the tangent line through the point, through the x value that we chose of -1 on the derivative function there. Okay, hope that helps. See you in the next one. What is a normal line? Let me show you. Let's graph this function here. We're going to graph x squared minus x minus 6. Looks like that. And the tangent line is right here, and that's the tangent at the point -1, -4. It's about there. So the tangent line goes like that. Except just pretend that it goes through that point, because I missed it. So it goes through that point. That's the tangent line. So the normal line, first of all, let's calculate that real quick. So normal line, n of x equals, it's going to be just like the tangent line, except the slope is going to be the negative reciprocal. So it's going to be, the normal line is -4 plus 1/3, because the slope there of the tangent line is -3. Negative reciprocal of that is positive 1/3, x plus 1. So that is the equation of the normal line. So that is going to be perpendicular to the tangent line. So what does it mean? So it's the line that shows the direction in which the curve is not tilting at all. So the tangent tells us how k of x is changing. The normal tells us the direction where that change disappears. All right, hope that helps. See you in the next one. Say you've got a parabola and a line. How do you determine where they intersect? Let me show you. So we're looking at this parabola here. Looks like that. And this line here looks like that. And we're given that they intersect at x equals -1. So right about here. But we can see that they also intersect here. So how do we find that second x value where they intersect? Well, first thing we do is set the parabola equal to the line. And let's do that. So -4 plus 1/3 x plus 1. And then we can simplify a bit. Let's say x squared minus x minus 6 equals -4. Distribute the 1/3, so 1/3 x plus 1/3. Multiply everything by 3 to get rid of those fractions. We'll get 3x squared minus 3x minus 18 equals what? -12 plus x plus 1. Okay, now we'll get everything over to one side. We have 3x squared minus 4x. Let's see, -18 plus 11 is -7 equals 0. So now we use the quadratic formula. X equals -b plus or minus square root b squared minus 4ac all over 2a. And here a equals 3, b equals what? -4, and c equals -7. So we just plug those values in. We get x equals, let's see, 4 plus or minus square root b squared minus 4ac. So b squared is 16. A times c is -21 times 4 is, so 84, since it's subtracting. Okay. All over 2a, which is 6. Okay, we have, so x equals 4 plus or minus square root of 100, which is 10 over 6. So let's see, negative 6 over 6 is negative 1. And we have that one already. That's this one up here. And then let's see, 14 over 6 is 7 over 3. So there it is. So that is where they intersect, where x equals 7 over 3. All right, hope that helps. Thanks for watching.